Now I am going to explain about the Perceptron Training rule on gradient descent on delta rule. Okay, where we are using the Perceptron Training rule on gradient descent on the delta rule, where we are using these two rules in a neural network. Okay, Perceptron Training rule means updating the weights where we are getting the misclassification data in the network. We are applying the Perceptron Training rule means updating the weight to each and every neurons, updating the weight values for the each and every neuron. That is the Perceptron Training rule. Here to gradient descent on the delta rule. Okay, in the gradient descent on delta rule, here calculating the error in the network. That network is the feed forwarded network. Okay, now I am going to explain about the Perceptron Training rule on gradient descent on delta rule. Okay. First one is the Perceptron Training rule. How the learn the voice for a single perceptron. Okay, what you mean by single perceptron or single perceptron layer? Your single perceptron means the artificial neural network is based on a single unit. That unit is called a perceptron. Here the precise learning problem is to determine weight vector that causes the perceptron to produce the correct one, output of the each of the given training example. The Perceptron rule and the delta rule. Here to applying the Perceptron rule and delta rule. One way to learn the accepting the weight vector is to begin with a random weights. Here we are starting with the random weights. Then iteratively applying the Perceptron to each training example, modifying the Perceptron weights whenever it misclassification an example. Where we are getting the misclassification data, that time we are applying the Perceptron Training rule. Okay, here Perceptron Training rule means updating the weight values. Okay, this process is repeated, iterating through the training examples as many as time need until the Perceptron classifying the best classification means correct data. All the training examples are correctly. Okay. Weights are modified at each step according to the Perceptron Training rule, which we reveals the weight. Okay, WA is associated with the input values is according to the. This is the Perceptron Training rule. Okay, here the WA is the constant weight values. Here updating that. Here the triangle of WA is updating the weight values in the network. Okay, here means triangle of WI is equal to the neta into t minus o into x of I. Here and neta indicating the learning rate. Here the t is the target output of the current training example and o is the target output of the current training example. Here the xi is the input values. This means updating the weight values in the network. Okay. We are getting the best classification till the we are updating the weight values in the network. Okay, here the triangle of WI is equal to neta into t minus o into x of y. Here neta is the learning rate, t is the target output of the current training example, and o is the output of the current training example. Okay, into number of inputs xi. Okay, and next one is the gradient descent. Here the target output for the current training example, y is the output is generated by the perceptron and q is the positive constant called the learning rate. Okay, neta is the positive constant and learning rate. Okay, the role of the learning rate is to moderate the degree to which weights are changed to each step. Okay, which weights are changed to at each step. Okay, and next one is the here the for example, if the values are x of I, here the input value is equal to 0.8 and neta value equal to 0.1 and t equal target output is equal to 1 and output is the -1. Then the weight is the update will be. Here the formula for updating the weight in the network, that is the triangle of WI is equal to neta into t minus o into x of I. Here the neta value is the 0.1 into, here the t is the 1 minus of 1, o is the minus of 1 into 0.8. Here we are getting the result is the 0.16. Okay, here updating the weight value is the 0.116. Here also apply substituting some values into the formula, that is the updating the weight values in the network. The next one is the gradient descent on the delta rule. The perceptron rule is find the successful weight vector when the training examples are linearly separable. Means linearly separable means best classification data. Non-linearly separable means misclassification data. Linearly separable means positive or negative examples are separating the one straight line. Okay, positive examples are the one side and negative examples are the one side. Here the positive examples in the positive side and negative examples are the inside in the other side. Okay, this is the linear separation. When the linearly separable means best classification data. Non-linearly separable means misclassification data. That time we are applying the gradient descent on delta rule. Okay. Here the second training rule is called the delta rule or gradient descent rule. Here using the gradient descent rule. Okay. Overcome this overcome this problem means which problem? Non-linearly separable. Okay. Already we have discussed in the powers of perceptron. Okay, linearly separable and non-linearly separable. Linearly separable means straight line is separating the positive and negative examples, and one more example is the non-linearly separable means there is no straight line between the positive and negative examples, means non-linearly separable. Okay, here the delta rule is to use the gradient descent to search the hypothesis space a possible weight vector to find the weights that is best fit the training example. Here the gradient descent can serve the basis of learning algorithm that must search through the hypothesis space containing the many different types of continuously parameterized hypotheses. Okay, the delta training rule is the best understood by the considering the task of training under unthreshold perceptron means threshold perceptron means peak value. Unthreshold perceptron means less threshold and minimum threshold value, that is the linear unit for which the output is given by order of E. Here the output of x forward direction means in the network linearly separable means forward direction. Linearly separable means forward direction. Here the output of linearly forward direction is equal to the input weight values are associated with the input value. A linear unit corresponds to the first stage of perceptron without the threshold value. Okay. In order to derive a weight learning rule for the linear units, let's begin by specifying the measure of the training error of a hypothesis space, where we are getting the misclassification data, where we are getting the non-linearly separable. That time we are calculating the error. Okay, that time we are calculating the error in the network. Okay, related to the training example, error of weight, where we are updating the weight, that time we are getting the error of weight in the forward direction is equal to the half of the square difference between the target output and output of the current training example. Half of the square difference between the target output and output of the target example. Okay, here where the capital D is the set of training example, a small d is the current training example. Here TED is the target output of the training example, and OD is the output of the linear unit of the for a training example. Okay, these are the two rules for the updating the weight values and finding the error. Okay, updating the weight values and finding the error. Where we are updating the weight values when we are getting the misclassification data, that time we are applying that time we are updating the weight values. Okay, till we are getting the best classification data, we are applying the perceptron training rule. Okay, and here the gradient descent delta rule, by using the gradient descent rule. This gradient descent rule, we are finding the error in the network. Okay, where we are getting the error in the network. Okay, we are updating the weight, that time we are getting the error, we are calculating that error. Okay, that error of weight is equal to half of the square difference between the target output minus or target output on, and next one OD is the output of the current training example. Okay, these two rules are used in the network, artificial neural network. Okay, Thank you.